Hello there. Welcome to PCB. I'm going to talk about hazard, hazard identification, risk assessment, and determining control. This is one of the most important element of occupational health and safety management system, ISO 45001 2018. As a safety professional and of course as an auditor, you must have very clear concept on hazard identification process, risk and risk assessment process, and how you determine controls, the hierarchy of controls, and how an organization must implement them, and how you as an auditor would audit that requirement. Let's dive in. So it's hazard identification, risk assessment, determining control. Risk is defined as likelihood of occurrence and severity. So you have to assess, while assessing risk, you have to assess likelihood of an occurrence, how likely an incident or accident can happen, and severity, what can go wrong if really something happens. So this chapter is designed to impart the knowledge and understanding on the concept of hazard and risk, hazard identification and risk assessment process, including the determination of controls. Being part of the prior learning, this chapter has been removed from the timed content of IRSA lead auditor program, which will not be discussed in detail, and you must have a thorough understanding of this requirement before you join the course. So I'm creating this video to address that prior learning needs that you must have before you joining an occupational health and safety lead auditor program. During the course, we'll have an overview of the requirement, but this knowledge would be very essential for you to have before you join the course. Now, what is hazard? Look at this picture. There's an excavation going on for, say, pipe laying or something like that. So there is an excavator, there some kind of excavation happened, some shoring material is there, some people are working. There is ladder for people to go down there and come up from there. And people are working at various levels, and there's a loose sand. So you can imagine there are two equipment there. There's one vehicle on the backside, one here. So there are a lot of movement of equipment. So this is an activity ongoing. So you have to identify what are the hazards here. So let's talk about first, what is hazard? Hazard is a situation or act with the potential for harm in terms of human injury, ill health, or a combination of this. So a situation or a condition or some action, some activities which has a potential for harm, bodily injury, or ill health. Ill health means something you are inhaling over a period of time, for example, H2S gas in a site, hydrocarbon vapor, you are taking smokes. In a fabrication industry, a lot of welding is happening. Noise, for example, a lot of noise all around, vibration. So these will have potential to cause ill health over a long period of time. So hazard is defined as a situation or an act with potential for harm in terms of human injuries, ill health, or combination of this. What are the types of hazards? One is physical hazard, which can contact with your body, which can harm to your body parts. For example, a limb injury, something you are hammering, you are working with a hammer while driving a nail on the wall, you can injure your fingers. So that's a physical hazard. So hammering on a nail has got physical hazard. Physical hazard could be anything that cause bodily injuries. Chemical hazards. Chemical hazard is basically reactions. For example, Bhopal gas tragedy, there, there were methyl isocyanate gas which leaked, which killed a lot of people. Thousands of people were killed because of this incident. So it's a chemical hazard. Chemical reaction can cause toxic release, which can cause death or physical injury. Biological hazards. When you are working, for example, COVID was a biological hazard for the doctors, right? Psychosocial hazards. Psychosocial hazards are hazards that happens at the place of your work. So psychological and sociological issues, for example, bullying, for example, intimidating or sexual abuse or those kind of things. So which has got a social aspects or psychosocial hazards. So now identify this. For example, physical hazards. This is a physical hazard. Somebody is doing some work with the grinding wheel or cutter, so they can have. Just imagine this gentleman doesn't have an hand gloves. So if something goes wrong, he can have a serious injury on your finger. So this is a physical hazard. You have got the drums. Drum is basically chemical, but they're stored in a way they can fall, and if barrel starts falling, that can cause physical harm and injury. So these are physical hazard as well. Now, physical hazard, just imagine these are gas cylinders. Now, sort of chemical, but when you are handling or someone is handling, these can fall on your leg and can fall down from the vehicle while transportation and stuff like that. So there is a potential for physical harm. So these are some of the examples of physical hazards. Chemical hazards, as I said, content of these barrels are chemicals. So if they're exposed, there could be kind of chemical reaction. For example, they may be having for example, hydrochloric acid or sulfuric acid or some toxic gas and stuff like that. So there is hazard from those chemicals. Biological, they are doing some testing. So these kind of laboratory tests can have biological agents. That kind of biological hazards can be there. So this is an example of biological hazards. Just imagine this lady is under huge stress from work. So this is an example of psychosocial hazards. Now, physical hazards could be slippery or uneven ground, working at height, objects falling from height, right? Inadequate space for work, poor ergonomics. If you are working in a different level where you have to lift up weights and work, or your chair is not a comfortable one and you have to work for a long time, so you will have ergonomics hazards. Manual handling, if you are lifting up weights, there are a lot of people lifts up weight and work, carry bricks and carry material. Manual handling is hazard where you can have back and neck injuries, stuff like that. Repetitive work, typist, continuously they are doing typing, and after some time you'll find problems with the fingers and your wrist. um, Trapping, entanglement, burn, and other hazards arising from equipment. Sometimes in equipment you're working and something has happened, the person can be dragged inside the machinery and equipment. For example, a rotating equipment, a fan, suddenly some loose safety gear, loose garments, loose end is picked up, and the fan will just start pulling you towards the hazard. So this is called trapping or entanglement. That kind of things can happen. Transportation hazards. On road transportation, there are a lot of hazards. Transporting goods, moving on the road, driving on road, stuff like that. So fire and explosion, very common hazards. Fire and explosion happens a lot. Explosion can happen in explosive industries, firecracker industries. Fire can happen at home, fire can happen in the oil and gas facility or any other facilities. These are all part of example. Harmful energy sources, for example, electricity or radiation, noise or vibration, stored energy, which can be released quickly, can cause positive harm. For example, high pressure system. Suddenly, there's a rupture or a collapse of a vacuum tanker. So these are kind of potential for physical hazards. Frequently perform repeated tasks which are regularly done, called repetitive motion injuries. Repetitive motion injuries means something you are doing over and over and over again, and by doing that you develop um, some kind of physical harm. Ionizing radiation, X-ray, gamma ray, non-ionizing radiation like light and magnetic and radio waves, etc. Those kind of things. Chemical hazards, substances hazardous to health or safety due to inhalation of vapor or gas or particles. You can have this situation: contact with or being absorbed through the body, ingestion, storage, incompatibility or degradation of material. Those kind of things are example of that. Biological hazards, biological agents, allergen, pathogens such as bacteria or viruses. In the hospital, there are a lot of nurses and the doctors are very vulnerable to biological hazards. People are going with different types of viruses or bacteria, and those kind of things are a serious biological hazards for them. This can be inhaled, transmitted via contacts, including bodily fluids, insect bites, for example, ingested, or via contaminated food products. Imagine COVID crisis, what a trauma we all had. We have seen what is real devastation virus can do. We are protecting ourselves, covering ourselves, cleaning our hands frequently, covering our mouth and nose with masks and all that, covering full body and stuff like that. You have seen how devastating COVID-19 virus was. It's an example of biological hazard, psychosocial hazard, a situation that can lead to negative psychological, including psychosocial, such as stress, post-traumatic stress, anxiety, fatigue, depression, etc. Excessive workload could be part of that. Lack of communication or management control, workplace, physical environment, physical violence, bullying or intimidation, all those kind of things. So now let us identify some of the hazards. A deep excavation for a foundation work is going on. So identify what are the types of hazards here. So now just imagine somebody is working here, or there is improper shoring. They should be in a 45-degree angle, properly spaced, or there should be separator and with a kind of a cylinder in between. They are separated. But if something falls, the person there can get trapped and get buried alive, and this has happened. Potential for electrocution from buried power cables. Imagine there's a buried power cable or here, or there is a facility here. You can see a red line, maybe a water pipe going through that. So while excavation, the backhoe, this blade, this backhoe bucket can hit this and cause a problem. If there's an electrical cable, there can be electrocution because directly the metal body can transfer the electrical power to the driver, or somebody adjacent to that can get electrocuted. So these are kind of potential hazards. So fall in the excavation. This guy can fall in the excavation. Accident due to excavation. This equipment can fall and hit them. Injury of the person from backhoe. This man is looking at here. He's talking. Maybe this person did not see and he got a bad hit from the backhoe by the driver. Collapse of the earth and buried alive, and physical injuries and confined space. Now, this space more than 4 feet deep is a confined space. So confined space is where access is possible, but egress coming out or going out of the place is limited. Anything greater than 4 feet deeper is considered to be confined space. So these people are clearly working in confined space. There may be accumulation of gas, toxic gas or otherwise, that they inhale, and this man is unable to come up and he may die out there. So these are the kind of hazards can happen. So these are type of typical hazards with excavation. Now, just I want you to identify this very interesting work. See, this gentleman is looking at, there are a lot of boxes here. He's very relaxed and watching this. There is some equipment this forklift is trying to take up with the help of another forklift. So one forklift is resting on the fork of the bigger forklift, and this forklift is having this machinery and equipment that is putting out on the first floor, and the people are sitting on the edge, and clearly they're on the first floor height. So it looks like these guys are at the edge. These people are standing. If something happens with this equipment, this guy can fall. So fall from height. This guy is working standing here. He can sleep and fall. If there's a vibration, he can fall. And at that point of time, the forklift can also fall on him and killing him. And if this falls, this guy is also injured. And just see one more guy standing there. So this guy can get trapped in between these two because he is unable to see. So this is only hazard, and I cannot imagine this kind of operation can happen in real life. But this picture is given for you to understand or appreciate these kind of things people can think, and these kind of risks are also possible. Let me now talk about how you identify hazard and do the risk assessment. What is the process? So identify the hazard first. This can be done by procedure. This can be done by identifying the hazards physically, and you document all those things in a register. This process can be done by visual inspection, by knowledge, by different techniques. So identification of the hazard is the first. Then you assess risk. Now the risk, as I mentioned, is a product of likelihood and severity. So this is where we are going to assess the risk from that hazard. Now, there are different techniques called HAZOP study, FMEA, failure mode and effect analysis. HAZOP is you are actually looking at hazards from operation. What if? What can go wrong? What if this doesn't happen? What if this happens? Those kind of studies called HAZOP study. Hazard and operability studies HAZOP. Next is FMEA, failure mode and effect analysis. Failure mode and effect criticality analysis. FTA is called fault tree analysis. ETA is called event tree analysis. These are some of the techniques that can be used to assess risk. Once you identify the hazards and assess the risk, and that is when you have to determine the controls. How to eliminate the hazards or eliminate the exposure, eliminate the risk. In this first place is elimination. How do you establish control? The control hierarchy is first eliminate. Try to eliminate the hazard. If you can eliminate the hazard, then the potential of exposure is reduced, so there will be hardly any chance that there will be an accident. For example, if you don't go to the road, you are not vulnerable from a road accident, right? If you don't go to the height, you are not going to fall from the height. So if you can avoid or eliminate something, eliminate it. Substitute. So substitute is an alternate process. So for example, if you have got a better way of doing it, so if you can substitute, you can have a reduced level of potential of occurrence. So risk also is going to be reduced. Engineering control. Just imagine engineering control is some control which is provided by some engineering designs and consideration. For example, somebody is working at height. So if you put a handrail, that's an engineering control. You cannot say, okay, you don't have a handrail, but we'll put some sandbags or loose sand. So if somebody falls from the top, will not have an injury, because basically we are talking about personal protective equipment without providing the handrail. So handrail, if it is possible, you have to put it there. Then sign, put the signs at working, and then you give personal protective equipment. Once you have this, then look at whether those controls have been implemented or not. If elimination is possible, have they eliminated? If elimination is not feasible, have they substitute with a better or safer process? And whether engineering controls have been brought in, and then science and administrative controls, for example, permit to work and stuff like that, and then provided PP. That does not mean all of them can happen together based on their priorities, but this is the generic hierarchy of control you would expect to be there in place. For example, you cannot live with that hazard having no engineering control, only providing a personal protective equipment. But you may have to give personal protective equipment at the same time, try to reduce the impact by better or safer process by substituting and bringing in engineering controls. So all sort of controls that is required has to be brought in place. But this is the principles of hierarchy. Once it is done, you have to monitor whether the risk has been reduced and is there any incident or accident occurring. If this happens, then you have got a better and safer place, and then you further improve again. So these continues in the place of work. So this is the process you are going to continue to ensure your hazards are identified, risks are attained, controls are determined, controls are implemented, and a better and safer process is brought in place. Risk assessment process: first identify the hazards and then determine the risk, and then is the risk acceptable? You have to see uh, yes or no the answer. Prepare the risk management plan, and in the plan, of course, pre-implementation adequacy review of risk management plan, and then you implement the risk assessment plan, risk management plan, and review the plan for adequacy of the risk management. We are now going to talk about risk assessment tools and methodologies, how you assess risk in reality. Observation. First is you see visually, you have got adequate knowledge and competence. So, observation is the first thing. You can see some hazards lying there, some potholes, some objects which can fall, or some missing guardrails, or whatever potential that you can visually see is the first method of identifying the hazards and determining, of course, the risk. Checklist and questionnaires. There may be a more structured way of looking at, look at different things and fill up a checklist, and that will give you what all kind of risks and hazards are there. Task analysis. You can look at the task. What are the steps the process involves? How the activities are being performed? Is there any risky activities? For example, last week I was in an audit. I found there is a gas cutter who was doing gas cutting of beam for a structural fabrication. Absolutely brilliant, skilled person. He doesn't need a guide. It's absolutely perfect cut. But when I looked at, I just stopped him that when you are doing gas cutting, the slags are falling down. And just below this is the oxyacetylene pipe coming in. Now, oxyacetylene pipe comes in and supplies the gas to the nozzle where the control is in his hand. So if there is a fire from any broken and cracked the pipes, hose pipes carrying oxygen and acetylene, The control in the cylinder is quite far by the time it can cause a serious fire incident. So basically, what I was looking at, how he is doing the task. And in the task, I found there are some risky activities. Slacks can fall. So I was looking, yes, he's adequately protected with safety shoes and all that, hand gloves and eye protection, head protection, all these things are fine. But this is one of the observation we made. So from the task analysis, you can look at what is happening. So observation, failure mode and effect analysis. Failure mode and effect analysis is a process. For example, a car met with an accident and there was a fire. Now look at, there was a fire in the car. That was effect, ultimate effect. So what did happen? So looking at, you found the temperature has risen. Why the temperature is risen? The cooling system did not work. Why the cooling system did not work? Actually, there was a leakage in the radiator. The water got dropped because radiator did not function in absence of coolant, and this happened because of a leakage. So leakage caused no water and the coolant to drain out, leaving nothing to cool the engine, and because of the heat and temperature, and there was a fire in the car. So this is how one failure can lead to the failure of another system. Another system can ultimately lead to the accident. So this is called failure mode and effect analysis. Hazard and operability study, HAZOP study. HAZOP study is very commonly used in construction and new construction activities, new projects, or new system design. Hazard and operability study came from what if analysis. What if this does not work? What if this happens? What if the temperature is high? What if the temperature is low, for example? What if the pressure is high? What if the pressure is low? What if the upper limit switch doesn't work? Stuff like that. What if the pressure relieving device does not work? Things like that. Imagine there is a tank, vertical storage tank, which stores crude oil or finished product. Now, imagine there's a floating roof where the roof is resting on the liquid level. So as you fill up, the level of the liquid will go up. Along with that, the floating roof will go up. Again, when you are pumping out crude oil or finished product, the liquid level drops down. Along with that, you have the roof of the tank is also coming down because this is resting on the liquid level. Now just imagine while pumping, at certain point, the filling should stop. So that's the higher limit switch for filling level. What if that limit switch doesn't work? The pump will continue to pump. And at some point, it will fill so much that the floating roof can come out of the system, causing a serious accident and a disaster. So working of the upper limit switch is very important. So the question is, what if it doesn't work? So there is a high level limit switch, which will possibly send trigger to slow down the pump. And when the level reaches the high level, that is when the pump should actually trip. Now, if that was not there and you continue to pump in, it can happen that the roof comes out of it. So this is called HAZOP and operability study. What if the level is high? What if the barrique unit, which is the pressure vacuum unit, doesn't work? The tank can crumble. A fixed cone roof tank can crumble when they're pumping out crude oil because there'll be vacuum created. And in that vacuum, the whole tank can crumble. because it can cause an implosion. And that is when the barrack unit will allow some amount of air to come in and to maintain the balance. That's how you maintain the safety of the vessel, safety of the tank. After hazard and operability study, there is another very good method of determining hazards and assessing risk is fault tree analysis. Fault tree analysis, we'll talk about this little more in detail. It's a very interesting concept. Fault tree analysis is what kind of faults can lead to another failure, and that can lead to another failure. So, fault tree analysis, we will show, is a process of determining by analyzing the sequence of faults that ultimately led to a failure. And then event tree analysis. We'll talk about them little more in detail. Basic tool for hazard identification, look for potential hazard, visible, invisible hazard, which is like a health effect, behavioral aspects, following compliance to the rules, way people work. These are some of the observation. So there are something called 4 P's of developing a checklist. Premises, first is premises, where things are happening, and then access, egress, housekeeping, and all those kind of things, work environment there. So look at the premises while developing a checklist. Plant and substances. Plant and substance, the machinery and equipment we are talking about. The first one is the place, second one is the plant and services, machinery, guarding, storage of substance and the chemicals, like storage of the barrels and stuff like that, exhaust, vibration, procedure, compliance to procedure. Procedural compliance is very fundamentally important, like permit to work system, for example, work authorization process or closeout process. Before you go for a work, you look at whether there is permit to work, whether they are allowed to start work. And the permit to work system, what happens is, in the permit to work system, what is done is this is a kind of a work authorization that someone authorized will look at whether the permit applicant has assessed the hazards or the risk or job safety analysis, and then they will prepare a request for the work. These are the kind of work involved. These are the kind of hazards present there. These are the precautions that we are going to take, and that's how we are going to decommission the system, and that's how we are going to work on that. And this is how we are boxing up and returning back the system back into service, those kind of things. The next is people. One of the most important element of the safety management system is the people. They are the one who is doing the work. They can do the work safely or in an unsafe manner. So the people, their human behavior, yeah, is very important. Authorization, the person that they are doing are authorized or not. Their competence, for example, is very important. Task analysis, we have mentioned about analyze the all aspect of the task, emphasizing the hazard and risk involved. Break down the work in steps. It's called work breakdown structure. Look at what all can go wrong. For each step, identify safe working method, work instruction, workman protection, what all safety rules and regulations, emergency response and procedure, reporting the hazards and communication, and effect of the place or the layout. Task analysis is performed based on this. Now, task analysis, take an example. For example, valve in a flare line. The valve is located at 4 feet deep in the valve pit. So imagine a work will be done. People will work in a valve pit, which is 4 feet below the ground level. So, of course, 4 feet down means it's a confined space. So this needs some kind of a preparation. So how you are doing the task analysis, safe working method, how they are going to remove the valve and dismantle it and take it out. Imagine it's a flare stack, flare line, which is going to cause storage or accumulation of heavy and toxic gases, maybe very harmful or maybe lethal. So these will be there, heavy ones will be coming down to the pit. The moment you open the valve, they will come out and they can heat. So what is required? Safe working method, how to lift it, how to remove the valve, how to lift the valve and take it to the surface, and all those kind of things. Work instruction for removal, handling, reinstallation, checking the presence of any gas, or continuous monitoring the gas. Maybe in the beginning there was no gas. The moment you opened, people opened the flanges and loosened the studs and bolts, that there may be a huge leakage or gas coming out of the system and filling the pit where people are breathing and they don't have breathing mask, they can be immediately affected. So workman protection, all those kind of things, and safety rule, permit to work, emergency procedure. If something goes wrong, how you take them out and reporting the hazards. So this is how the whole process can be done. The hazard identification and risk assessment, failure mode and effect analysis. All right. So aim of the study is to assess potential hazard by analyzing failure modes and how this failure can affect the overall system. I've given the example radiator leak because this caused temperature to rise and overheat, causing the gasket to failure and fire in the engine, damaging the car seriously. So this is the kind of failure mode and effect analysis. Fault tree analysis, very interesting. These symbols are very important. This is symbolizing an event, and this is called AND gate, this and that. And this is called OR gate, this or that. Let me explain the fault tree analysis. Look at this, picture. So this is fuel and oxygen and ignition. Fire is a triangle. So if there's a fuel and there is oxygen and source of fire, then there will be a fire. So there may be fuel and oxygen in the surrounding, but without a source of ignition, there'll be no fire. So these three coming close together closes the triangle and cause the fire. Imagine in a place you've got petrol or kerosene, which is inflammable. You've got paper or jute that is also inflammable. You've got plastic and paint, these are also inflammable. So these or this or this or gate will cause a fuel to be present. Oxygen is already there. Now, electrical fault could be a source of ignition or a cigarette butt somebody is throwing, or sabotage or a spark or any source of ignition. Maybe a sparking hammer, steel hammer can cause a spark. So that could be a source of fire. So source of ignition is there. So these or these can be source of ignition. So now you have got fuel and oxygen and ignition can cause a fire. So this is how we have to check. We have to eliminate those inflammables or prevent these three things to come in contact with each other for prevention of a fire. Now let's see how this can be quantified. Say there is 50% of the chance that in this place there is fuel or petrol or kerosene, something flammable. Imagine in a fuel station or in a gathering center, there'll be paper or other stuff, plastic. So zero point 0.5 plus 0.1 plus 0.2 is 0.8 is the chance of fuel being present there. Now, oxygen is there, so it is 100% it is there. 0.4% is the electrical fault can cause a source of an ignition. Then cigarette butts, say 20% chance. A lot of people are smoking and people are smoking around. They can throw the cigarette butts. So there is a greater chance. And sabotage is a 10% of the chance is sabotage. So all three things together is 0.04 plus 0.2 plus 0.1 is 0.34. Now these and these and these is the combination of 0.8 into zero point 0.1 multiplied by 0.34 is 0.272. This means if all these conditions are present and something goes wrong, there is 27.2% chance that there can be a fire. That's how you consider an accident that can happen. That's the possibility of an accident. Now, in inventory analysis is focused on identifying and evaluating the consequence of an event, right? And I will show identify the initiating event, identify the assigned control or detect to mitigate and stuff like that. Construct the inventory with initiating event and presence of condition that may affect outcome positively or negatively. And then establish loss or event sequence and identify critical failure that needs to be monitored and quantify the tree if data is available, e.g. likelihood, for example, likelihood or frequency. Let us see that this event tree. Say there is a fire. Now, can it be detected or not? Yes, it can be detected because there is a fire alarm system in place. Or no, this cannot be detected that there is no fire alarm system, so even if the fire, this cannot be detected. Now if this can be detected, well, it's fine, you have detected it, but do you have a mitigative system in place? Can you prevent this from happening further? There is a fire, but can it be stopped from propagating? Yes, if this is possible, then the damage would be very limited. Now, if you have got detected it, but there is no way to prevent the propagation, then extensive damage can happen in spite of fire being detected and fire alarm system working. Now, if this cannot be detected and there is no process to stop the propagation, extensive damage can happen. Now, just imagine there's a fire and there is no fire alarm system at all in place. This means there is an extensive damage and probable fatality. Now, the first one, no, and second one, no, is slightly different. First one is, yes, it can be detected. Detection system is there, but fire alarm system did not work, maybe malfunction, maybe for some reason. So therefore, there is a need for testing. And in this case, it is not there at all. So if it is not there, there is no way of detection. If it is there, this might work, might not work. So it needs calibration testing and so on. And once it is detected, then you need to have, for example, foam spreader will work or automated deluge system will start working. You can start the internal foam spreader or monitor can be activated quickly so you can control the damage to a limited extent. That's how. So for example, fire is 2% per year is a probability and detection capability is this, so 95% it can be detected, so 0.5% it cannot be. Now in this you find 0.98% fire alarm system works, 98% of the time fire alarm works, 2% it doesn't work. And then in that case, foam spreader works 96% of the time, 4% it does not. So if you start adding them, the damage potential is 0.02 into 0.95 into 0.08 into 0.96. It should be 96. This gives 0.178 per year. That means there's 1% chance that if the fire breaks out, there can be limited damage. Like that, you can consider, calculate, and this is a very unlikely situation. The fire is not detected 0.02% and the foam spreader and other system did not work 0.04. So if you multiply 0.2, 0.02 and then 0.95 and then 0.02 and 0.04, that gives 0.00015. There's a very negligible chance of an extensive damage. When fire is there, it is not detected, fire alarm system did not work, and of course, the foam spreader and mitigative system did not work. That's how you can construct the event tree analysis. So, as I said, risk is likelihood of occurrence and severity. So, if you consider a hazard is like a cause, the risk could be an effect of that. So how do you consider the effect, overall effect? The likelihood, how likely it is to happen, and how severe it can happen if the incident really happens. So likelihood is basically probability of occurrence, and severity is the consequence of the harm. So likelihood can be very likely that it is almost certain to happen, all likely this can happen. So you can give a numerical value, say 2, and then unlikely, say 1, or even you can say 0, 1, 2, 5 also you can give this numerical ranking. This can be just a matter of your own imagination or basis for some calculation. In the severity, is major fatality, death, and loss of facility and long, term disability can happen. So say this is 3. A lot of people can die. Catastrophic consequence can happen. Moderate short-term injury, broken limbs, ill health, etc. of 1 or 2%. You can say numerical value is 2, and minor, maybe somebody got some minor injuries, say little bruises and minor injuries, finger cut and stuff like that, couple of hours of rest. So these are the kind of severity. Now, how do you define likelihood of occurrence? Most likely 3, very high chances or likelihood of occurrence due to work activity, control, measures, or process unpredictability. And there is evidence that similar thing really happened before, and quite frequently it happens. Likely is to that there are examples that something has happened. Controls are in place, but still it is probable something can go wrong. Unlikely is it's not really likely, it really doesn't happen, but there is a possibility. For example, Fukushima power plant, nuclear power plant in Japan, it worked for so many years and decades, but there was one tsunami, and at that same time they had a high, earthquake together devastated the plant. So it was very unlikely, but really it happened. So this is how we consider the likelihood. And severity is minor condition which may cause some minor injuries. Moderate is more extensive damage, and major is catastrophic, huge, the entire plant has gone, permanent disability or fatality of persons, mass poisoning or contamination with cross boundary effect, such as atomic power plant failure, tank farm, or an entire facility is on fire, costing the entire facility, which causes serious occupational health and safety concern. That's how you can define the severity rating. Now, if you put the likelihood, unlikely, likely, and most likely, and severity, minor, moderate, and major, this multiplied by this field will become risk field, which is likelihood and severity multiplication. So now, if you look at unlikely and minor, 1 multiplied by 1 is 1. Minor and likely, 2 into 1, 2, 3 into 1, 3. Like that, 2 into 1, 2, 3 into 1, 3, 2 into 2, 4, 2 into 3, 6, 6, and 3 into 3 is 9. So you can say up to 2 we'll consider it's low. Above 2, up to 6, or below 6, we'll consider the risk to be medium. So 3 or 4 is medium risk. Above 4, it is considered 6 or 9 is high risk. So these are the high risk areas. So if something is most likely to happen and the catastrophic consequence can happen, clearly this is the highest level of risk at 9. So our intention as the risk managers or assessor is to find, is there any way to reduce the medium risk to a lower level? Or if you can reduce the likelihood from 3 to 2, this risk will become low risk. Or if this risk likelihood is 2, all right, likelihood is 3, and in this particular case, most likely likelihood is 3 with moderate severity. So if we can reduce it to 2, so this risk becomes medium, it becomes 4 instead of 6. So our intention is either to reduce the likelihood or the severity by protection, by ensuring controls. That's how risk assessments are done. So, for example, this is a typical way of presenting risk, hazard identification, and risk assessed in the program. Working at height, these are the potential hazards: fall from height, falling objects, electrocution. Likelihood is 3 to 1. Severity, if somebody falls from height, it could be 9. Now if you see 9 is highest risk, so here we put them in highest risk. So this is the highest risk category is 1. So fall from height and working at height is the highest amount of risk. So install fall arrest system, provide training, and provide site supervision. By doing that, you bring that risk to an acceptable level, and this program will happen immediately within a month, and training has to be given, say, within 2 months. So by doing that, these potential or the likelihood of this occurrence can be brought down to 2, and severity also can be brought down to, say, 2. So in that case it becomes 4, it becomes like moderate. For example, if it is 2 into 2, 4 means it becomes medium risk. So the high risk can become moderate risk. So you can say by doing that, remaining risk will be 4, which is medium. So high risk has been brought to medium risk. So this is how you can identify the activities, the hazards associated, likelihood, severity, multiply this, and then get the risk, and then rate the risk, and your priority would be on the highest risk, and then bring in controls to bring those risks to an acceptable level, develop a program, how soon, how fast you are going to act on this. Qualitative risk assessment is an approach or a concept that, yes, there is a very high risk or a low risk. Sometimes risk cannot be measured. For example, you are driving on road, there is a risk, but what is the percentage of risk, you really don't know, but which is fine for you to even appreciate that there is a high risk, that it looks like based on your experience, and you should be alert, you should have proper control on the vehicle, you should have proper driving license, alertness. Don't drive with when you are under medication or some effect of drugs and stuff like that, which can impair your ability to drive properly. Your response system may be retarded and stuff like that. So qualitative risk assessment is a qualitative assessment of the risk without putting a numerical value. For example, and quantitative risk assessment is that you can put some numerical value for a visualization. For example, in this case, we have shown this the risk category, and we have identified these risks to have a numerical value of 9. So this approach is actually quantitative approach basis. Now, the biggest problem is giving these numerical values. Now, sometimes you can say, okay, it's not very likely, so you give a lower rating but or higher rating, or here most severe or less severe. By doing that, you may have a different numbering. Based on that, your results can also be different. Therefore, you must identify quantitative risk assessment with a logical approach.